and that too pair. Hello students, welcome to today's class on linear equations in two variables, and that too pair of linear equations. That means we are discussing about two linear equations at the same time with the two variables inside that. My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So what is this pair of linear equations in two variables? Let us take one condition or one situation where a person sitting is going to some shop and she's buying 3 notebooks and 2 pens. She bought 3 notebooks and 2 pens for rupees 80. Okay, and there is one more friend, Lakshmi. She also purchased 4 notebooks and 3 pens, 4 and 3. Here it is 3 and 2. Here it is 4 and 3 of the same kind for rupees 110. Okay, so here the total cost is 80 rupees. Here the total cost is 110 rupees. So now the point is, how to find the cost of each notebook and each pen. So how to represent this mathematically, and then how to find the values of each notebook and each pen. So these type of situations we are going to discuss in this topic of pair of linear equations. So there are two situations, so pair and two variables, one is notebook and one is pen, right? So how can we know the cost of one notebook or the cost of one pen? So let us try to represent notebooks and pens with some x and y. Okay, let's try to represent the cost of one notebook is x and the cost of the pen is y. Right? So Siri has bought 3 notebooks and 2 pens for rupees 80. 3 notebooks and 2 pens for rupees 80. 3 notebooks. 3 times of each notebook is x rupees plus 2 times of each pen is y rupees is equal to rupees 80 rupees, correct? And the next girl, Lakshmi, bought 4 notebooks and 3 pens. 4 notebooks and each notebook is x rupees plus 3 pens, 3 times of y, each pen is of y rupees is equal to 110. 3x plus 2y is equal to 80 and 4x plus 3y is equal to 110, right? So another point is how to take these two equations and how to solve for the values of x and y. X is the cost of notebook and y is the cost of pen. So we'll try to learn how to solve this type of equations algebraically as well as graphically. We have different methods as well as with the graphs. So in this class we are going to discuss about these type of equations where we are going to find the values of x and y, right? So moving ahead, linear equation is an equation with a degree 1. We discussed that in the previous classes, right from your lower classes. You know, linear means a degree 1. What is the degree now? You may get it out. Sir, what is degree? We forgot. Can you please recall? See, whenever you have an equation like something like x square plus x plus 1, let us say, or an expression. Okay, here the highest index of x, the highest index of the variable is a 2, x square. So the degree of this variable is a 2. The degree of this expression is a 2. In the same way, linear equation is degree 1. So x power 1 plus some 2, that is a expression with degree 1, x power 1. The highest index should be equal to 1. Highest index should be equal to 1, right? If the linear equation has 2 variables involved in it, if the linear equation has 2 variables, see here where I discussed with the example only with the 1 variable. But now if I discuss with 2 variables, that means x as well as y, both are there in the equation. Not only x and y, you can take any 2 variables, a and b, p and q, right? Depending on the situation, we take a different variables. That's not a point here. If the linear equation has 2 variables involved in it, we call linear equation in 2 variables. We call linear equation in 2 variables. So how the equations will look like with the 2 variables? I'll give you a small example. 2x plus 3y is equal to, let's say, 6. That is a one simple linear equation in terms of x and y. Both the variables power is 1, the highest index is 1. So it is a first degree linear equation in 2 variables. This is a linear equation, this is a linear expression in 1 variable. Equation, that means you need to have something like this, equality. Linear equation 1 variable, linear equation in 2 variables, right? So every linear equation represents a straight line. In the lower classes we learned the graph of a straight line, that is always a straight line. I mean, graph of a linear equation is always a straight line, right? We saw how to plot the graph of y equal to x plus 1, taking different values of x, bring out y, and plotting them on the graph paper. Once again, let's try to take some examples. Don't worry about that. But still, so every linear equation graph will be a straight line. And depending on the graphs or depending on the situation, when we're taking two equations, because it's a pair, two equations, sometimes those two lines may intersect, sometimes they may not intersect, that sometimes they coincide. That means one on the other. So depending on the equations, we get different cases of graphs. Let's try to discuss all those, right? So the thing is, how does a graph look? Straight line, we know that. Okay. What is a solution we need to solve? And in today's class, we're going to discuss how to solve a pair of linear equations and how to find the solution. Okay. What is a solution and how to find the solution? See, what a solution means, sometimes it may have one solution, sometimes it may have infinite solutions. Sometimes the pair of equations may not have any solutions. So based on all these, we're going to discuss, right? So pair of linear equations represents two straight lines. Why two straight lines? Because it's a pair. Pair means two. Pair means two. So two linear equations represents the two straight lines, obviously. One linear equation will give you one straight line. So two equations will give you two straight lines. Okay. So sometimes it may represent a parallel lines, which are moving in the same direction. Parallel, which do not meet any time, which never meet, never intersect, right? Or sometimes we have coincidental lines. That means one line on the other. This is one line, that is a blue one is the other line. So both are being coincident, right? And we may have intersecting. These two lines are intersecting at one point. Lines, they may intersect at only one point or no points. Okay, they cannot intersect at 2 points, they cannot intersect at 3 points, although there are infinite points. These are actually not intersecting lines, these are coincident lines. The same line is being repeated, right? So let's see more information about this one, pair of linear equations. And this is a standard form. Ax plus by plus c equal to 0. Ax plus by plus c equal, this is a standard form. Ax plus by plus c equal to 0. This is a standard form of the representation, right? And as we have a pair of linear equations, to give a difference between these two, to differentiate between these two, we write a1 b1 c1 and a2 b2 c2. These two are two individual linear equations. Okay. Solution of pair of linear equations is the value of variables x and y satisfying both the equations. Solution of a pair of linear equations is the values of x and y. So what we need to find, if you want to find the solution, simply we need to find the values of x and y. Simply we need to find the values of x and y satisfying both these equations, right? Graphically, so what do you mean by graphically? Okay, once we got solution, but what is the importance or what is the significance of that solution graphically? Graphically, it is a point of intersection. It is a point of intersection of the two lines formed by the equations. Point of intersection. See, when I have lines like this, intersecting lines, there is a point of intersection. And that represents the solution. That's what it is giving, right? Solution is a point of intersection. So that point itself will be the solution which satisfies both the lines. Sometimes the lines may be parallel which never intersect, and we can say that there is no point of intersection or there is no solution. Here we have one point of intersection, so one solution. Here there are no points of intersection, so no solution, right? And coincident lines will actually intersect at infinite points, and we get infinite solutions. You may have no solution, you may have one solution, or you may have infinite solution. You will never get the case where you have exactly two solutions, exactly three solutions. No. In pair of linear equations, we cannot get that. Okay. So let's discuss all those once again. If the pair of equations has a solution, if they have solution, That means they are consistent. What do you mean? What we say? If they are having a solution, either it is one or infinite, one solution or infinitely many solutions, we say them as consistent. The word consistent says that they have a solution, one or infinite. Okay. Graphically, the lines intersect or coincide. I told you that just now. Okay. Has a solution means they either intersect or they either coincide, line on the same line. Okay. They either coincide, correct? If the pair of equations has no solution means no point of intersection. These two lines will never meet each other, right? They are said to be inconsistent. They are said to be inconsistent, and graphically the lines are parallel. The lines are parallel. Understood? Once again, let's discuss all these points once again. If the pair of equations has solution, we say consistent. If they don't have solution, we say inconsistent. Solution, consistent. No solution, inconsistent. When we have inconsistent, the lines are parallel, because you know parallel lines will never intersect, will never touch, will never meet, right? That is the reason. Inconsistent means no solution. That means they are parallel lines. And when we have a solution, it may be intersecting or coincident lines, coincide, right? Let's move forward. So here we have different cases, as we have just told you. Either they have one solution or no solution or infinite solution. But without graphically, just by seeing A1, B1, C1, A2, B2, C2, how can we judge or how can we conclude that yes, these lines have one solution or no solution or infinitely many solution, right? So let's see that if this condition is satisfied, A1 by A2 is equal to B1 by B2 but not equal to C1 by C2, then these are called parallel lines. These are called parallel lines. Parallel lines, I'll give an example. 2x plus 3y plus 4 is equal to 0. And I'll give you one more. 2x plus 3y plus 5 is equal to 0. You may say that these two are the same equations. No, they differ in the constant term. So, a1 by a2, 2 by 2 is equal to b1 by b2, 3 by 3. That is correct. 1 is equal to 1. But which is not equal to 4 by 5. So, these type of cases, these type of lines are called as parallel lines, and there is no solution for this equation. There is no solution. Number of solutions. If I ask you number of solutions, you need to say that it is 0. It is 0, right? The next one we are talking about intersecting lines. The next one we are talking about intersecting lines. Okay. In intersecting lines, a1 by a2 is not equal to b1 by b2. a1 by a2 is not equal to b1 by b2. Okay, a1 by a2 is not equal. I'll give an example here. 2x plus 3y plus 5 is equal to 0, and 3x plus 4y plus 7 equal to 0. There may be some solution, okay, whatever it is. But you can see 2 by 3 is not equal to 3 by 4. 2 by 3 is not equal to 3 by 4. It is enough. It is enough to say that these lines are intersecting, and as we discussed in the previous slide, intersecting lines means they have one solution. They have one solution, unique one solution. Here we have no solution or zero solutions, right? And as we discuss this too, we should also discuss the other case where the lines are coincident lines, okay? Coincidental lines where all a1 by a2, b1 by b2, c1 by c2 are also equal. All the things are equal. I'll give you an equation. 2x plus 3y plus 4 is equal to 0, and 4x plus 6y plus 8 is equal to 0. So now these are two different equations. For appearance, these are two different equations. But when you carefully observe, 2 times of the first equation is second equation. 2 times of the first equation is second equation. That means actually these two are the same equations. Line on the line, they coincide. They coincide means we get infinitely many solutions. At infinite number of points, those two lines are meeting. Those two lines are meeting. Understand? No solution, parallel lines. One solution, intersecting lines. Infinitely many, coincident. And what are the reasons? What are the conditions? A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. If it is equal, it becomes C1, it is coincident lines. And the very first two, if these two are not equal, we say they are intersecting lines. This is a very important derivation, a very important step, because without plotting the graph, directly we can say that yes, these lines are parallel, they have one solution, they have no solution, intersecting one solution, coincident, infinitely many solution. And when we're discussing about consistent and inconsistent, I told you, here we have no solution, this is inconsistent, okay? This is inconsistent. And these are consistent. These are consistent. Intersecting and coincident lines are consistent. That means they have a solution. Right? So, yeah. So, we have written here. So, let me erase that part for you so that you can easily identify what we have written. Okay. So, this case, we'll be having inconsistent because there are no solutions. Here we have consistent because we have one solution, and here also it is consistent because we have infinitely many solutions. There exists solution, right? If a solution is existing, we can say that they are consistent. So these two cases are consistent, and the very first case is inconsistent, right? So let's move forward for the next one. Find the nature of following pair of equations. Find the nature of following pair of equations. So that means we need to say whether they are intersecting or coincident or parallel. How can we do that? Using the information just we have seen that, okay? 5x minus 4y plus 8 and 7x plus 6y minus 9 is equal to 0. So what is A1, A2, A1, B1, C1? This is A1, B1, C1, A2, B2, C2. So what is A1 by A2? A1 by A2 is 5 by 7. B1 by B2 is equal to minus 4 by 6, which is equal to minus 2 by 3. So now are these two equal? These two are not equal. It is enough to say that A1 by A2 is not equal to B1 by B2. It is enough to say that these lines are intersecting. These lines are intersecting. And I told you intersecting lines will have one solution. Intersecting lines will have one solution. Find the nature of following pair of equations. They are intersecting. Are they consistent? The question is, are they consistent? Yes, they are consistent, because for intersecting we get one solution, and yes, we can say that they are consistent. Yes, they are consistent. Right. So let's move forward to the next one. Find the nature of following pair of equations. So we have a couple of more questions here. So A1 by A2, 18 by 8, 18 by 9 is equal to B1 by B2, 6 by 3. Are these two correct? 9 ones, 9 twos, 3 ones, 3 twos. Yes, these two are equal. Okay. And which is equal to 24 by 12? Is that correct? 18 by 9 is 2, 6 by 3 is 2, 24 by 12. 24 by 12 is also 2. So we can say that yes, all the three are equal. So we can say A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Right? So we can say that they are coincident lines, and coincident lines are consistent. Coincidental lines which have infinite solutions, There are infinite points of intersection between those two lines. Are they consistent? Yes. The question is, yes, they are consistent. Right. So let's move forward for the next question. The only thing you should keep in your mind is A1 by A2, B1 by B2, C1 by C2. And if all the three are equal, we say coincidental lines. If the first two are equal but not the last, they are parallel. And the first two, if they are not equal, we say they are intersecting. Right? The before slide we have discussed all the cases. Find the nature of pair of equations 6x minus 3y plus 10 and 2x minus 5 plus 9. Are they consistent? So 6 by 2 is equal to minus 3 by minus 1. Minus 3 by minus 1 is equal to 10 by 9. 6 by 2 is 3. Minus 3 by minus 1 is 3. Which is not equal to 10 by 9. So what happened in this case? A1 by A2 is equal to B1 by B2, but not equal to C1 by C2. This is the case of parallel lines, if you remember. This is the case of parallel lines, and I said you, for parallel lines, they have no solution. We say inconsistent. We say, are they consistent? No. Are they consistent? No, they are inconsistent. They don't have any solution. They don't meet at any point. They don't meet at any point. Correct. Let's move forward for the next question. Plot the graph and find the solution of x minus 2y plus 2 equal to 0. So to find the solution, we have different methods. The first one we're going to discuss is graphical approach. In the same way, we also have algebraical approach. We can try to solve equations directly without the help of graph. But as we discussed just now that they meet at one point, they don't meet at one, they don't meet, or they're coincident. So let's try to see that along with the graphs to get a better idea, right? So let me take few points here. Okay, let me label the graph 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 1, minus 2, minus 3, minus 4, and 1, 2, 3, 4. This is how your graph paper will look like. This is how your graph paper will look like, correct? So this is 3. Let me write it properly once again. 3. So the very first question, x minus 2y plus 2 equal to 0. X minus 2y plus 2 equal to 0. Let me keep x equal to 1 or x equal to 2, right? Or keep x equal to 0, it's more easy. If x is equal to 0, we get 0 minus 2y plus 2 equal to 0. Minus 2y is equal to minus 2. And y is equal to 1. 2y is equal to 2, y is equal to 1. So the point we need to take care here is 0, 1. The point we need to take care is 0, 1. In the same way, let's keep y equal to 0 in this equation. If we keep y equal to 0, we get x plus 2 equal to 0. So x is equal to minus 2. So the point is a minus 2, 0. 0, 1 and minus 2, 0. So let me plot this point. Let me plot this point. 0, 1, 0, 1 on x-axis 0 and y-axis 1. So this is the point 0, 1. And the other point is a minus 2, 0. Minus 2 and on x-axis minus 2, 0. So this is the point, right? So now we need to join these two lines. Join these 2 points to get the graph of this line, right? So let me try that properly. Let me try as far as possible, something like this, right? It goes in that way. Okay. The next one we're going to discuss is the next equation, x minus y minus 1 equal to 0. If you keep x equal to 0, okay, I'll write the points here. If you keep x equal to 0, you get minus y minus 1 is equal to 0. Minus y minus 1 equal to 0. Let me write it a big. Or I can erase this part, right? Okay. I'm discussing about x minus y minus 1 is equal to 0. If x is equal to 0, we get minus y minus 1 equal to 0, minus y equal to 1, y is equal to minus 1. So one point is 0, minus 1. One point is 0, minus 1. So where is 0, minus 1? Okay, 0, minus 1 is this point, right? This is 0, minus 1. Let us take one more point in this one. We'll keeping y equal to 0. If y is 0, x minus 1 equal to 0, right? If y is 0, x minus 1 is equal to 0. So we'll get x equal to 1. So the point is 1, 0. So where is 1, 0? 1, 0 is somewhere here. So the point is, are these 2 points intersecting at some point? Are these 2 lines? Let us draw this line. Okay. Let me try how best I can do. Right. Wait a minute. Let me draw it properly again. Right, something like this. Okay. So these 2 will never intersect at this point, but these 2 will intersect at some point here. At some point here, as per my graph. Maybe 4, 3. I'm not sure. Maybe 4, 3. 4. Yes, that's correct. Okay. So the point where these 2 are meeting, here you can see this is a 4, this is a number 3. So this point is 4, 3. That point is a 4, 3, right? So if you can see carefully, 4, 3 should satisfy this equation. 4 minus 3 minus 1. 4 minus 4, 0, correct. The same way here. 4 minus 2 to 3 to 6 plus 2. 6 minus 6 is 0, correct. So I can say that the solution is a 4, 3. Okay. Plot the graph and find the solution. Solution is that they meet at 4, 3. They meet at 4, 3, correct? Okay, how to get that 4 comma 3? Because it is exactly at the number 4 and number 3, x on 4 on x and 3 on y. So those 2 points are intersecting there, which is a 4 comma 3, right? In the same way, we'll take one more question, but I'm not going to plot it properly completely. Okay, this is for your reference. So but I'll tell you how to represent this mathematically, and so that you can try to plot the graph. 5 pencils and 7 pens together cost rupees 50. 5 pencils, so I'm taking pencil as x and pen as y. Pencils as x and pen as y. So we can say that 5x plus 7y, 5x plus 7y together cost rupees 50. So this cost is 50 rupees. And whereas 7 pencils and 5 pens, 7 pencils and 5 pens, 5 pens is equal to 46. So these two are two equations. So now what you need to do? Take x equal to 0, give y points, take y equal to 0, get the x points, and plot these two lines on the graph paper and see where they are intersecting. Are they intersecting at any point or not, first of all? Are they consistent or inconsistent? And from there you can try to find this graph. From that graph you can find what is the solution. The point where it meets, you'll get the solution, right? So in the next class we are going to discuss about a substitution method. That is the algebraical method. Just now we have discussed about a graphical method. In the next class we are going to discuss the same solution, how to get that using algebraically without the help of graph with some methods. In that first we are going to discuss about the substitution method, right? So thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone, welcome back to the chemistry session. Let's continue our journey of the chapter of atomic structure. So far we have understood about the many things in the atomic structure chapter, right? Our last session ended with the understanding of electromagnetic radiations. There we had understood what are EMRs, that is electromagnetic radiations, and what is electromagnetic spectrum, right? So after electromagnetic spectrum understanding, we will understand about the atomic model of Bohr. But to understand the atomic model of Bohr, we need to understand Planck's quantum theory, right? Planck's quantum theory. What is Planck's quantum theory? We'll go through it. So once it is done, then we will go to the Bohr's atomic model, right? Now, but before starting the lecture, let me give you an introduction about myself. My name is Karan and I am an IIT Varanasi graduate. So from the time of my graduation, I am teaching students chemistry who wants to crack JEE as well as NEETs. Along with that, I also take the foundation courses, that is from 6th to 10th. Now the reason behind taking the foundation course is that the students should be able to have a competitive advantage in solving, in understanding the concepts which usually students start late, right? So once you will start these topics at the early stage in the earlier classes, you will develop your mental aptitude, which you can utilize in understanding the concepts very easily, and in enhancing your problem solving capability. Okay, so that is all about the reason why you are being taught this chapter at such an early stage. If you go through your CBSE, ICSE, any kind of book, you will not find this chapter in the 9th class or in any class. In any class you will not find this chapter. Okay, this chapter comes in 11th class only, 11th standard. But I am teaching you here so that you have a advantage in developing the understanding of this chapter, right? So that is all about the introduction. Let's go to the chapter. Now today's agenda will be covering the 9th lecture and starting the 9th lecture with the Planck's quantum theory, right? Before starting this topic, let me give you an idea about what we have gone through in the last class. In the last class we have gone through this one, electromagnetic spectrum, right? And I have told you about this one. These things were understood in the last class, right? Where I have told you what is EMR spectrum and what is spectrum actually, right? In the last class we had gone through the visible spectrum also, which was developed by using the visible light, right? So now let's start with the topic of EMR spectrum, and that is Planck's quantum theory, and let's go ahead. Let's go ahead. Yes. Now the Planck's quantum theory is what? Basically this quantum theory is very helpful in understanding the Bohr's atomic model. When I say Bohr's atomic model, that means what? That means, remember in the Rutherford, Bohr was the person who pointed out to Rutherford that his atomic model has some inaccuracies, right? And that after that it was Bohr who improved the atomic model. So Bohr's atomic model is an improved version of Rutherford's atomic model. Okay, that is the basic idea. But to understand Bohr's atomic model, we need to understand this topic, right? Now this theory says what? According to the Planck's quantum theory, he is the major scientist. He is the major scientist who is responsible for this theory. His name is Max Planck. His name is Max Planck. Max Planck is the scientist who gave us the Planck's quantum theory. Now this theory says that according to this theory, according to the Planck, the energy of the electromagnetic radiations. Now we know electromagnetic radiations are what? They are a form of energy only, right? And we know electromagnetic radiations, they propagate, they move in the form of wave, right? We have understood this thing, that this is how the waves move. This is how the wave moves, right? So the scientist said that energy of this EMR, energy of this electromagnetic radiation, it propagates in the form of packets of energy called photons. In the form of packets of energy called photons. What is the meaning of this thing? What is the meaning of this thing? See, important point is that we know what is EMR. We know what is EMR. We know that James Maxwell, he had told us that these electromagnetic radiations, they are wave. According to James Maxwell, EMR, electromagnetic radiations are wave in nature. They are wave in nature, right? What is the meaning of this thing? That EMR are wave in nature? Simple. If these electromagnetic radiations, they are wave in nature, that means these radiations, they will have their wavelength, frequency, velocity, wave number, right? Simple. We know we have gone through the characteristics of wave, and in the characteristics of wave we have gone through these different properties: wavelength, frequency, velocity, and wave number, and amplitude also, right? So as we know that electromagnetic radiations, they are also wave. So that means they will also have some lambda, right? They will also have some frequency. That is why we have divided, that is why we have divided the electromagnetic radiations in different formats according to the lambda, according to wavelength and frequency. You see, this range is a different wave, different electromagnetic wave. This range is a different electromagnetic wave, and this range, it's a different electromagnetic wave. This range is different electromagnetic wave, right? How are we differentiating? Based upon their wavelengths and frequency, right? So that means EMRs, they have wave nature. They are of wave. They are also waves. Max Planck, he is the scientist who said that electromagnetic radiations, they have particle nature also. They have particle nature also. They have particle nature also. Now, what is the meaning of particle nature? Right? He said that these waves, they have particle nature. Now, what is the meaning of particle nature? That you need to understand. Right? Wave nature we have done. Wave nature we have already done. Particle nature kya hai? What is the particle nature? That we need to understand. Right? So he said that energy of the EMR, it propagates in the form of packets of energy. Packets of energy is called photon. See, simply if I talk, suppose this is the person. Right? Suppose this is one person. Suppose this is one person. Right? So this person can, when the sunlight comes, when the sunlight is coming, if this person is standing there and this is sun, right? This is sun. Just a second. This is my sun, right? And the person is standing there. So this person, it will receive the light. He will receive the light like this. Right? He will receive the light like this. If this person is standing under the sun, he will receive the light like this. And what is light? These are what? EMRs. These are electromagnetic radiations. Right? Now Planck says that these radiations, when they reach the person, when these radiations, they reach this person, the energy of the radiations, right? The energy of these radiations, they reach the person in the form of energy of packets. The energy of these radiations, they reach this person in the form of packets of energy. So just do one thing. One day, try to stand under the sun for 5 minutes. Try to stand under the sun for 5 minutes. So you will say your body will get heat up, right? Your body will gain the heat. If you touch yourself after 5 minutes, your body will be heated up, right? Why does it happen? Why your body gets heated up? Because the energy of these radiations, EMRs, it travels to you. The energy of these radiations, EMR, it travels to you in the form of photons. That is packets of energy, right? Packets of energy is photons. So suppose you will receive the energy like this. These are the little packets. These are the little packets which are coming along with the EMR. Along with the radiations, these are the energy packets. These are the energy packets which you are receiving. Means every packet, every dot, every red dot is what? Every red dot is a packet of energy. These are the packets of energy. Okay, these are the packets of energy. And these packets of energy, they are not continuous, they are discrete. They are discrete. These are the discrete form of energy. Discrete form of energy. What is the meaning of discrete form of energy? This we need to understand, that what is the discrete form of energy. So one thing is clear, that whatever energy you are receiving from the sun, when you stand under the sun, it is coming on the waves, right? So you can think that photons are little particles. You can assume that this is the photon, this is the wave which is coming. The wave starts from here. It reaches here. Right? The wave starts from here, it reaches here. And the energy particles are just sitting on the wave. Okay? When this wave reaches you, energy particles reaches you. Simple. You can understand like this, that these energy particles are actually they are actually sitting on the wave. And when this wave from sun reaches you, these energy particles also reaches you. Okay? These energy particles, they also reaches you. Understood how it is happening? Let me give you an example. For example, look at here. So you see, this is energy particle. Just think that this is energy particle. This is photon. This red dot is photon. Photon, which is packet of energy. This red dot is photon, which is packet of energy. Okay, this red dot is actually the photon, which is packet of energy. It travels on the wave. The wave is moving like this, it is also moving like this. Right, and suppose you are here, right, or suppose you are here. So it will reaches you. See, it is reaching you. It starts from here, it comes here. It starts from here, it comes here. Right, so this is how photon reaches you. This is how the photon travels on the wave. Photon is what? It's a packet of energy. Packet of energy. Packet means simple. Just a second. Yes. Packet of energy means simple. This is a packet. Like here. These dots. These are the packets. Full packet of energy. Right. So means one photon is one packet. I will say one packet of energy. One packet of energy is called one photon. Understood? One packet of energy is called one photon. This is all you need to understand. This is all you need to understand. That how these radiations, they are reaching the earth, how these radiations are hitting you. Hitting means you are standing like this and you get warm. You get warmed. How? Because these packets of energy, they are traveling on the wave. They are traveling on the wave and they are reaching you. Just understand like this. Just understand like this. Right? And these are discrete form of energy. It's a discrete form of energy. Discrete means what? Discrete means, let's take the example. Let's take the example. Suppose I have this car. Suppose this is my car. Suppose this is our car, right? Suppose this is another car. Suppose this is our another car. Right? These are our cars. Sorry. This is one car, this is another car. Now suppose at this height, from this height, suppose you do one thing, you throw the ice cube. This is the ice cube. From this height, you throw the ice cube. Right? From this height, you throw the ice cube. This is case 1. This is first case. When from that height, you throw the ice cube. Second case is that hailstorm is occurring. Hailstorm. Right? Have you ever seen the hailstorm? Mostly you will see this hailstorm in the northern states. Right? Not in Hyderabad, rarely in Hyderabad or in other states, or in south you will see this hailstorm, but in hilly areas. In hilly areas, in the northern areas, in northern country, you will see these hailstorms. That little we can say ice packets. Little ice packets, they fall. Like this. Right? Like this, little ice packets fall. Right? Now the point is, when this ice cube, suppose this ice cube, right? Suppose this ice cube is here. It falls. When it falls on the windscreen, this is my windscreen, right? This is my windscreen. Windscreen of the car. When this ice cube will fall on the windscreen of the car, it will create impact. When this ice cube will hit on the windscreen. This is the windscreen, right? When this ice cube will hit the windscreen, what will happen? It will create an impact, right? It will damage the windscreen. It will damage the windscreen, right? It will damage the windscreen. So what is happening? It's a discrete, one by one. It's a discrete source of energy. It's a discrete source of energy. Discrete source of energy means it is coming one by one. That means what? Suppose you drop this ice cube. After that, you drop another ice cube. After that, you drop another ice cube. So you are dropping the ice cube one by one. First you drop this one, then you drop this one, then you drop this one, right? So one by one, these ice cubes, they will hit the surface. They will hit the windscreen and they will damage the windscreen. Here, what is happening? In this case, hailstorm. Hailstorm is just like the rain. It's just like the rain. The way rain comes down, right? Suppose this is the windscreen and hailstorm is coming. This hailstorm is what? These are the ice cubes, or we can say sphere of ice. These are the sphere of ice, little sphere of ice. They come continuously. Just like the rain comes down, these are the ice cubes, ice spheres that also comes down continuously, right? So it's like in 1 second, 10, 20. In 1 second, you can say 5, 10 hails are hitting the screen. This is the screen. So you can say in 1 second, some 5 to 6 hails, they are hitting the screen continuously. So just like this, like this, they are continuously hitting the screen. So what will happen? They will further damage. They will also damage the screen. They will also damage the screen. These hails, they will also damage the screen, right? They will also damage the screen. But you see, here, when the hail, snow particle, hit the surface of the windscreen, it transfers the energy. It transfers the energy. What is the meaning of transfer of energy? See, simple. Right now, this is my hand. You see, this hand, it's stationary. It's not moving. But when I push it, it goes away, right? Right now, it is transferred. It's stationary. It's not moving. But when this is my hand, it comes with the energy. This hand comes with energy and hit this hand, right? When it comes with energy, hit this hand, it goes away. This hand, it goes away, right? It goes away. Why? Because this hand had the energy, moving energy, kinetic energy, right? It has the power. It hit this stationary hand and forced this stationary hand to move away. It supply the energy, transfer the energy to this hand and make it move away. Same thing is happening here. These hails, when they will hit the windscreen, these hails, when they will hit the windscreen, they will supply the energy. They will give away their energy, right? So these hails, they will strike here and they will stop. See, it is coming down with greater speed. These hails, they are coming down with some speed, right? If something is coming down, just like my hand, it is coming with the speed and it hit this hand and it stops. The moment it stops, it transfers all of its energy to this hand. Okay, the moment this hand stops, it transfers all of its energy to this hand. And this hand gains energy and it moves like this, right? Similarly, these hails, the moment they hit the windscreen, they will transfer their energy. But the point is, this windscreen is attached to the car and car is very heavy. So car cannot move. Car cannot move just like my hand. Just like my hand moves, car cannot move. So in this case, what will happen? These hails, they will damage the windscreen. They will damage the windscreen, right? But you see, in this case, you are throwing the ice cube one by one. One by one, ice cube is hitting the windscreen. There continuously, hails are hitting the windscreen, right? Here you see, continuously, hails are hitting the windscreen. Here, ice cube is hitting the windscreen one by one, right? So what will happen? In that case, damage is more. In this case, damage is more. In this case, damage is more. In this case, damage is less. Right? So it's just like the hammering of iron. Suppose you have a hammer. And you hammer a metal. Suppose this is my tin. This is my tin. right? Tin, and you have a hammer. Suppose you have a hammer. When you will hit the tin continuously, again and again and again, continuously, like you are hitting it, like this. So there will be a dent. There will be a dent in the top of tin. Right now the top of tin is like this. Later on it will become like this. Right now the top is like this, right? This is the top of tin right now. It will become like this. Because of depression. Because this depression is created upon hitting the tin from the top by the hammer. Continuously you beat. So this is the case of this one. Continuous hitting of hailstones on the surface of car will create the dents, right? And the damage is more. Here it is less. Suppose you are hitting the, just a second. Yes, suppose you are hitting the surface of the tin once. You hit once, you stop. Then you take some time, you hit again, then you stop. Then again you stop and hit. Stop, hit. In this case, the dent will not be there. There will be less dent. So in that case, dent will be that much. This much only, small dent. The dent is very small. Dent means D-E-N-T, depression. Okay, this dent is very small. It's not very big. But when you continuously hit it, continuously keep on hitting it, it will be very large. It will be like this. It will be like this. Same thing is happening here. Why? Because hailstorms are continuous source of energy. Hailstorms, they are continuous form of energy. Understood? Hailstorms are what? They are, just a second, they are continuous source of energy. Continuous source of energy means what? They are continuously, these hailstones, they are continuously striking the windscreen and continuously supplying the energy to the windscreen, right? Continuously they are coming tuck like this, right? So it will give more damage. Ice cube, you will throw it once, then stop. After 5 minutes, you will throw it again, then stop. After 5 minutes, you will throw it again. It will not give much damage because it's a discrete source of energy. One by one. It is continuous, keep on coming. So that means this is how the hailstorms are. Our photons are also like the hailstorms. Our photons, they are also like the hailstorms, right? So you see here, in this case of hailstorms, you see every hailstorm has mass, right? These are the hailstorms, right? This is my hailstorm. It is coming down with some weight. This hailstorm has some weight, right? It will have some mass. When it will come down, it will hit, right? It will hit. So that means it has some energy. This hailstorm has some energy. When it will hit the screen like this, when this hailstorm hit the screen, when it hit the screen, it will transfer its energy to the windscreen. So all the hailstorms, they have some energy. Every hailstorm has some energy and they will transfer their energy to the windscreen when they hit the windscreen, right? Understood? Yes. So our photons are like that only. Our photons, just a second. The photons are like that only. Photons are also the source of energy. Photons are the source of energy. They are the source of energy, or we can say photons are, just a second. Just like you see these hailstorms, these are one by one, right? One, another there, another is there, another is there. So these are little parts, little particles. These are the little particles, right? Similarly, photons are the packets of energy or particles of energy. These are the particles or packets of energy. Understood? Just like in this hailstorm, hails, snow particles, they are the packets of energy in the radiations. Similarly, in the radiations, just a second, I think, yeah, in the case of radiations, in the case of radiations, photons are the packets of energy. Okay, when these radiations they hit you, these radiations they carry the photons, like the hails. In the hailstorm you saw the hails. Here it's not the hail, it's the photon which contains the energy, right? So these are the packets of energy. Understood? This is how basically we understand what are photons. Photons are just the packets of energy which are hitting you, and they are riding on the wave. The wave is moving like this, they are riding on the wave. Understood? So ultimately, according to Planck, the energy of the electromagnetic radiations propagates in the form of packets of energy called photons. Just like energy of hailstorm. The hailstorm, when it comes down, it's hails, it's snowy particles, they have energy. Similarly, when electromagnetic radiations moves, flows, or it propagates, its photons have energy. Okay, its photons have energy. It is the photons that have energy. Understood? One thing. Now, substances, what happens? Substances, they absorb the heat or they radiate the energy discontinuously in the form of small packets of energy. Right? Just like here. This is me. Suppose this is anyone. This is some person XYZ. He is receiving the energy in the form of small packets. Right? He is receiving the energy in the form of small packets of energy called photons. So he is absorbing. That's why when you stand under the sun, what happens? Whenever you stand under the sun like this, you absorb the heat. Right? You absorb the heat. That means what? You absorb the energy. That's why your body gets heat up. Right? So same thing is this one also. When you stand here, you absorb the photons. So just like I am absorbing the photons, some bodies, they release the photons. Right? Sometimes some bodies, they release the photons. So when they release or when they absorb, when they release the photon or when they absorb the photon, it happens discontinuously in the form of small packets of energy. Okay? It happens discontinuously in the form of small packets of energy. The smallest particle of energy, this smallest packet of energy is called quantum. And in case of light, it is called photon. So basically photon is what? Photon word is used for light, or we can say photon is used for EMR. Just a second. Yes. Photon is used for electromagnetic radiations. Okay. Photon is used for electromagnetic radiations. This is why we use the photons. The word photon is actually used for electromagnetic radiations. Understood? So in case of light, it is called photon. Otherwise, just like in the case of hails, just like the hailstorm is coming down, right? Hails. In that case, that energy, that packet of energy is called quantum. Because hailstorms, they are not light. They are not electromagnetic radiations, right? They are not electromagnetic radiations. These are the hails, like the form of rain. But when it is sun, and when it radiates the energy, like this, it is the EMR. This is the EMR. And this EMR contains energy in the form of photons. Okay, this EMR contains energy in the form of photons. Understood now? Understood? Easy? Easy peasy? Right? Chalo. So now, I have told you that light is what? Light is a form of EMR, and every EMR has some specific range of wavelength and frequency. That we know. This thing is very clear to us. That what is light? light is an electromagnetic wave, and we know every electromagnetic wave has a frequency and a wavelength, right? Now every photon has some wave associated with it. I've told you that suppose this is my wave, suppose this is my wave, right? This is my wave. Then this photon is traveling on the wave, right? This photon is traveling on the wave. Just imagine that every wave has photon, and this photon is traveling on the wave like this. So that means every photon has some wave associated with it. Means every photon, this is the photon, it is associated with the wave. Which is the wave? This is the wave. Understood? Every photon is associated with the wave like this, right? Means the photon is riding the wave. The photon is riding the electromagnetic wave. Understood? So according to Planck, this photon's energy, this photon, its energy is associated with the frequency and wavelength of wave. Will it be? Will it be or will not be? Tell me. Is it possible or is it not possible? Just a second. Yes, I'm telling you that every photon has some wave associated with it. That means if this is my photon, this is my wave, right? And this is my another wave. This is my another wave. So you can see the difference between two waves. In this case, the lambda is more. This is lambda 1. In this case, lambda is what? This much. Lambda 2. In this case, the frequency is what? Nu 1. In this case, the frequency is nu 2. Right? And I have told you that every photon has some wave associated with it. Every photon has some wave. So suppose that this is the photon. This is the photon which is riding this wave, which is coming on this wave, and suppose this wave is hitting this object. This wave is hitting this object. This wave is coming and hitting this object. Second case, suppose here, this is the object. This wave is hitting the object here. This wave is hitting the object there. And suppose every wave, what is a wave? I have told you. One wave is what? One wave is that much. This is one wave, right? This is one wave, right? This is one wave. I have told you that what is the length of wave? This is one wave. This is a wave, right? So if this wave has this photon, if this wave has this photon, and if this wave has this photon, here also, there, this is one photon, 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 right? And now just imagine that, yes, now imagine that this wave has nu2 frequency. Its frequency is suppose 5 second inverse, and its frequency is 2 second inverse, right? This wave has 2 second inverse frequency, this wave has 5 second inverse frequency. That means in 1 second, 2